Okay, very good morning all of you. So, in the last class we have seen that few chemical properties of amines. In their first, basic nature of amines, alkylation, acylation, and very important reaction, carbylamine reaction, and reaction with nitrous acid. Okay, now we are discussing the chemical properties. One more reaction with benzene sulfonyl chloride. What is that? Reaction with benzene sulfonyl chloride. So this is also called Hinsberg reagent. This is very important. This reaction, carbylamine reaction, main reaction, and reaction with benzene sulfonyl chloride. This is also called Hinsberg reagent. So generally, this Hinsberg reagent is used to identify the primary, secondary, aliphatic and aromatic amines. So you can differentiate the primary amines, secondary amines, tertiary amines by using the Hinsberg reagent, that is benzene sulfonyl chloride. B is the short form habitually. Is it clear? So it's very important. It is used to identify the primary, secondary, tertiary amines. How? So generally benzene sulfonyl chloride reacts with generally primary amines. Here, by the removal of hydrogen chloride leads to the formation of N-ethyl benzene sulfonamide. What is that? N-ethyl benzene sulfonamide. Once again I am saying benzene sulfonyl chloride reacts with ethyl amine, which is a primary amine. Leads to the formation of N-ethyl benzene sulfonamide. So here most acidic hydrogen is there. So this is the most electron withdrawing group. Is it clear? Minus I group. So what is happening here? The hydrogen is most acidic. So because of this acidic hydrogen, that is soluble in alkali. Primary amines reacts with benzene sulfonyl chloride, forms N-ethyl benzene sulfonamide. These are nitrogen contains most acidic hydrogen, that is soluble in alkali. So this is the identification of primary amines. Come to the secondary amines. Benzene sulfonyl chloride when reacts with N comma N diethylamine. This is a secondary amine. Sir, this is a secondary amine. Reacts with benzene sulfonyl chloride, forms N comma N diethyl benzene sulfonamide. Here we don't have any acidic hydrogen. That's why that is insoluble in alkali. Is it clear? Now, benzene sulfonyl chloride is replaced. Nowadays, we are using the instead of benzene sulfonyl chloride, we are using the para-toluene sulfonyl chloride. What is the structure? CH3 plus double bond para-toluene sulfonyl chloride. Is it clear? So reaction with benzene sulfonyl chloride, there is a Hinsberg reagent used to identify the primary, secondary, tertiary. So we are saying up here is secondary. What about tertiary? Tertiary means it does not react with the benzene sulfonyl chloride. Primary amines reacts with benzene sulfonyl chloride, the product soluble alkali. Benzene sulfonyl chloride reacts with secondary amines, forms compound that is insoluble in alkali because lack of acidic hydrogen. Nowadays benzene sulfonyl chloride is replaced by para-toluene sulfonyl chloride. So this is a reaction with benzene sulfonyl chloride, Hinsberg reagent. Okay, now we will see that one more chemical property, that is a electrophilic substitution reaction in aniline. What is that? Electrophilic substitution reaction in aniline. So what is the electrophilic substitution first? one electrophile substituted by the another electrophile. So what is the meaning of electrophile? Electron loving species, that we call electrophile. So one electrophile substituted by the another electrophile, that is called electrophilic substitution reaction. So electrophilic substitution in the sense, first we have to check the where the more electron density is present on given compound. So come to the aniline. This is clear. So NH2, aniline which contains the NH2. This is a pair of electrons are present here. Yes, sir. So this pair of electrons involves the delocalization with the pi system of benzene ring. That is plus an effect. What we call that? Plus mesobaric effect. That releasing the lone pair electrons towards the benzene to get the way the more negative charge may obtain. That is known as plus M effect. Plus M effect simply says that delocalization of lone pair of electrons to a system, conjugated system. Now if you observe here, these pi electrons comes here, and here you may find that negative charge. So here pi bond moves to here, and here we will get a negative charge. At what position? Ortho position. Is it clear? At ortho position we have more electron density. Again delocalization takes place. Now at the para position we have more electron density, and now at ortho position we have more electron density, and finally the original structure value. So these are the few resonating structures. In these resonating structures we found that at ortho position, at para position we are having the more electron density because of the pressure effect of on aniline. Now bromination. So generally when aniline reacts with the bromine in the presence of water, when aniline reacts with bromine in the presence of water, forms 2,4,6 tribromoaniline with 3 moles of hydrogen bromide. Suppose if you want to get that monobrominated product, what we have to do? So here we are getting the tri-substituted aniline. For example, if you want to get the monobrominated aniline, what we have to do? So generally NH2 we are having a pair of electrons that is releasing into the benzene. So first what we have to do? We have to protect the aniline. How we can protect the aniline? So we have to react with the acidic anhydride. We have to react with the acidic anhydride. That is the acetylation. What is that? Acetylation. So by doing the acetylation on aniline with acetic anhydride forms acetonylide. So what happened here now? What happened here? So actually in this case the pair of electrons are moves towards benzene ring, but here pair of electrons are moves towards C double bond group. So finally what will happen? That electron density will somewhat decreases on the benzene ring. So now if you do that bromination in the presence of acetic acid, we will get para-bromoacetonylide. What we will get? Para-bromoacetonylide. This para-bromoacetonylide followed by hydrolysis. Gives that para-bromoaniline as a major product. Is it clear? So what we are explaining here? Bromination. So in the bromination general reaction, normal conditions, we will get the 2,4,6 tribromoaniline. So if you want to get that monobrominated aniline, what we have to do? We have to protect the amine. So the pair of electrons we have to protect. How we can protect that? First we have to do the acetylation. So we have to do the acetylation with acetic anhydride. So by doing this acetic anhydride reacting with acetic anhydride with aniline, that leads to the formation of acetonylate. So what will happen if acetonylate is formed? So the pair of electrons, instead of coming towards the benzene ring, moves towards the C double bond, that is the strong electron withdrawal. So what will happen there? So the electron density somewhat decreases on the benzene. So bromine reacts with the acetonylate in the presence of acetic acid. We get the para-bromoacetonylate. This para-bromoacetonylate upon hydrolysis get the monosubstituted aniline, that is para-bromoaniline. I hope all of you understood this one. This we are getting that 2, 4, 6 aniline in the absence of protecting the NH2 group, but by protecting the NH2 group with acetic anhydride, we are getting the monosubstituted bromoaniline. Is it clear? So now we will see that electrophilic substitution reaction. We have seen that bromination. Now we are seeing the nitration. What we are seeing that nitration. So see that carefully. In strong acidic medium. What is that? In strong acidic medium, aniline is protonated. So aniline is protonated. So to form anilinium ion. So what is an anilinium ion? NH3 plus. Is it clear? Anilinium ion. This leads to the formation of significant amount of orthonitro-aniline along with meta and para-nitroaniline. So what indicates that? Generally we have seen that electron density is more at ortho and para positions. Is it clear? So the electrophilic substitution takes place only at either ortho and para positions. But in this case, in the strong acidic medium, aniline is protonated. So acidic medium is that absorbs the H plus. So by absorbing the H plus, what will happen then? What will happen? That electron density slightly decreases on the benzene ring. Slightly deactivates the benzene ring, isn't it? So by deactivating the benzene ring, this leads to the formation of some significant amount along with that meta, along with that ortho, para, some significant amount of this is a meta-nitroaniline along with ortho and para. So here change that meta-nitroaniline along with ortho and para-nitroaniline. Is it clear? So see that when aniline in the presence of H2SO4 HL3 nitration mixture at 15 degrees Celsius, it forms para-nitroaniline, meta-nitroaniline, ortho-nitroaniline. If you observe the percentage, this is a 51%, this is a 47%, this is a 2%. So in the strong acidic medium, anilinium ion formation takes place. This anilinium ion formation leads to the formation of significant amount of meta-nitroaniline along with ortho and para-nitroaniline. Is it clear? So this is a formation of ortho, meta, para, nitroaniline. Okay, now we will see that mononitration on aniline. So still now we have seen that ortho, meta, para substituted aniline we have seen. Suppose if you want to get the mononitration on aniline. So in the last, the monobromination on aniline, first what we have done that acetylation on aniline. So to deactivate the ring. So the same thing we can do here. Is it clear? So when NH2 aniline reacts with the acetic anhydride in the presence of pyridine, leads to the formation of acetonylide. leads to the formation of acetonylate. So this acetonylate when reacts with the nitration mixture HNO3 H2SO4 leads to the formation of para-nitroacetonylate. What is that? Para-nitroacetonylate. So this para-nitroacetonylate undergoes the hydrolysis. Para-nitroacetonylate undergoes the hydrolysis leads to the formation of para-nitroaniline. So once again I am saying that nitration. So mononitration on aniline. So when aniline reacts with acetic anhydride, during the presence of pyridine, it undergoes acetylation, forms acetonylate. So this acetonylate undergoes reaction with nitration mixture, forms para-nitroacetonylate. Para-nitroacetonylate. This para-nitroacetonylate undergoes hydrolysis leads to the formation of para-nitroaniline. This is the nitration. So now we will see the sulfonation of aniline. Generally, aniline reacts with concentrated sulfuric acid. When aniline heated with concentrated sulfuric acid, that leads to the formation of anilinium hydrogen sulfate. What is that? Anilinium hydrogen sulfate. This is also called sulfonilic acid. This is also called as sulfonilic acid. So when aniline reacts with concentrated sulfuric acid, leads to the formation of anilinium hydrogen sulfate or sulfonilic acid. This sulfonilic acid at 453 to 473 Kelvin temperature, by the removal of water molecule, forms para-amino sulfonic acid. What is it? Para-amino sulfonic acid, and which rearranges to the Zwitter ion. What is that? Zwitter ion. So what is the meaning of Zwitter ion? The given species which contains cation and as well as anion. The same species which contains both cation and anion, that is called as Zwitter ion. So in the aqueous solution, the Zwitter ion can exist. Is it clear? So sulfonation, when aniline reacts with concentrated sulfuric acid, forms anilinium hydrogen sulfate, also called sulfonilic acid. This sulfonilic acid reacts heats about 453 to 473 kelvins, forms para-amino benzene sulfonic acid. This is rearranges to the Zwitter ion. The Zwitter ion means the species which contains both cation as well as anion. So that is in the aqueous solution. NH3 plus here, SO3 minus. So this is a sulfonation. Is it clear? So next we will see that aniline whether it undergoes Fidel-Craft reaction or not. Aniline undergoes Fidel-Craft reaction or not. Now we will check that once. So aniline whether undergoes Fidel-Craft reaction or not. So generally aniline does not undergo Fidel-Craft's alkylation or acylation. Generally aniline does not undergo Fidel-Craft alkylation or acylation. Why? So aniline, if you see that aniline, if it want to undergo the Fidel-Craft reaction, it has to react with the Lewis acid. What is that? AlCl2. Yes or no? When it reacts with the Lewis acids, forms stable salt. Forms stable salt which is strongly reactivates the benzene ring. Is it clear? So when aniline reacts with Lewis acid, that forms a stable salt that strongly reacts with the benzene. Strongly deactivates the benzene ring. So if it deactivates the benzene ring, there is no Friedel-Crafts alkylation or acylation. So no Friedel-Crafts alkylation or acylation takes place. Is it clear? So when aniline reacts with that Lewis acid, that forms a stable salt which strongly deactivates the benzene ring. So that cannot undergo Friedel-Crafts alkylation or acylation.